Okay, now we're going to have a look at Pythagoras Theorem, okay? And the theorem only ever applies to right-angled triangles, okay? And we can see this is a right-angled triangle here, and we've called the sides A, B, and C, okay? C is the bigger side, the longest side. It's opposite the right angle here, okay? And that also has a special name, hypotenuse, okay? So the hypotenuse is the long side that's opposite the right angle of a right angle triangle. Okay, now the theorem is as simple as this. C squared equals A squared plus B squared. Now that means that this length here, the length of side C, if you square it, would equal this side here squared plus this side here squared. And it always works, okay? Now one thing that we need to do quite often with Pythagoras theorem is that we want to find the length of C, okay, which we're going to do further down here, but just to show you, okay, we want to get C by itself. The way to get C by itself, we've got C squared here, is to take the square root of C squared. And just like we did with linear equations, whatever we do to one side, we have to do to the other, okay? So the square root of C squared is C. And over here we just have A squared plus B squared. So it's this version, even though this is Pythagoras theorem here, the top one, it's this one down here that really is of interest to us to actually use to solve problems, okay? And we'll look at that in example 2 in a minute. Okay, first of all, we'll look at a sort of a proof, I guess, and we come across these words triads. Some textbooks use the word triads, some talk about triples, and they're usually whole numbers that work for Pythagoras theorem. And a really well-known one that you're going to see a lot is the old 3, 4, 5, okay? And just to show that it works, okay, if C is 5, A equals 3 and B equals 4, and those two can be the other way around, it doesn't actually matter. Okay, then we would say, okay, just to show that it works, okay, so that would be 5 squared equals 3 squared plus 4 squared, and we just need to see if that's actually true. Okay, 5 squared is 25, 3 squared is 9, plus 16, and it does equal 25. Okay, so it proves that 3, 4, 5 is what we call a triple or a triad, okay? Now you'll be asked to test 3 numbers and see whether that's true. Always put the bigger of the 3 numbers, the biggest of the 3 numbers there, and the 2 smaller ones on this side. Okay, and just one other thing. If 3, 4, 5 is a well-known triad, any multiples of it are also triads, such as if we multiply all those numbers by 2, we get 6, 8, 10. That is also a triad, and therefore so is 9, 12 and 15, for example, okay? All right, so we'll move on to actually solving problems, finding side lengths. That's the most common use for Pythagoras theorem. First of all, we're going to find the hypotenuse, so the long side, C, okay? And here again, you can see here the formula that I showed up at the start. Okay, C equals the square root of A plus B squared, A squared plus B squared. So we just substitute in what we've got. Okay, this is our unknown, and these are numbers or values that we actually know. Okay, so A equals 5 and B equals 12, and it wouldn't matter if it was the other way around. Okay, C equals, therefore, we're applying this formula here. C equals the square root of, instead of writing A squared, I'm going to write 5 squared plus 12 squared. Okay, and we actually do that. And that's 25, so C equals 25 plus 144, the square root of C equals square root of 169 C equals 13. Now that's come out to exactly 3 whole numbers again. And that's no fluke, I picked those deliberately. That's another triad, a well-known triad, the 5, 12 and 13. Okay, the main point was to actually see the process here. They're not always going to come out to whole numbers in your answer. Okay, now the next thing we need to be able to do is to calculate one of the shorter sides, okay? So you can see in this triangle here that we've got 10 is the hypotenuse, 8 is one of the shorter sides, and we've got this other shorter side that we need to find, okay? So we have to rearrange the formula, okay? Now I'm going to go through this fairly quickly now, but there's the original formula or Pythagoras Theorem. C squared equals A squared plus B squared. Now I'm going to subtract B squared from both sides and just swap them around so that we get A squared equals C squared minus B squared. And just like we did up above, we take the square root of both sides. That makes this A. And then we've got the square root of C squared minus B squared. So this is the form of the formula we are really interested in here, okay? So now we've got, just like we did in example 2, very similar anyway, we've got B equals 8, we've got C equals 10, so we put them into the formula here, okay? A equals the square root of 10 squared minus 8 squared. Give yourself a bit of room here, whoops, okay? A equals the square root of 100 minus 64. A equals the square root of 36. A equals 6. Okay, and again, we've just got whole numbers. Okay, there's our answer. Okay, and you might remember above I spoke about multiples of 3, 4, 5. So maybe you already knew the answer before we worked it out. Okay. Now, please go on with exercise 6.2, questions 1, 2, 3, 4, 6 and 7, okay? And extension is 11 and 12. Thank you.